Hi and Assalamualaikum. In this video, our group, which is Slumberger Sendirian Berhad, will present our findings on the Field Development Plan 1. My name is Aiman Hakim. Will present our first finding in this video. The first chapter for the Field Development Plan is Geology and Geophysics. For the introduction, in general, Glamour Merah Field is located at the South China Sea, specifically 3 km northwest of Labuan and 130 km southwest of Kota Kinabalu. The first well, namely Glamour Merah 3, was drilled vertically from 151 meter to 2112 meter, and the second well, Glamour Merah 4, was drilled vertically from 148 meter to 2098 meter. In terms of regional setting, Glamour Merah is thought to have been deposited in the later part of Middle Miocene sands in a prograding delta and coastal complex depositional settings.
Now, we go to the petroleum system. Petroleum system is a geological processes and component to produce and store oil and gas below Earth. In this system consists of a mature source rock, migration pathway, reservoir rocks, traps, and silt. Two processes will take place in this production of oil and gas, which are trap formation and generation of hydrocarbon, along with the migration and accumulation of hydrocarbon. Appropriate time needed to make the formation of this element and processes to be a hydrocarbon reservoir. To determine a petroleum, a certain region we must understand, and fundamentals of hydrocarbon discovery are crucial to be understood. The first one is maturation. The location of Glamour Merah 3 and Glamour Merah 4, also with the Glamour Merah 5, are observed to be in the area of Brunei Sabah Delta, which the maturation process occurred in the stage of Middle Miocene to the present and assumed to have a deltaic accumulation at the convergence margin. Next, we go to the migration. The Miocene-Pliocene deltaic accumulation at the convergent margin was the migration assumption for Glamour Merah 3, 4, and 5. This migration, along with the fault, is probably a major method of migration of unconformity layers due to erosion. A migration through the sedimentary phases also has expected to be occurred, especially in an up-dip direction. The timing for the maturation is assumed to vary from the Middle Miocene to present. Next, we go to the migration. The Miocene-Pliocene deltaic accumulation at the convergent margin was the migration assumption for Glamour Merah 3, 4, and 5. This migration, along with the fault, is probably a major method of migration in unconformity layers due to erosion. A migration through sedimentary phases also has expected to be occurred, especially in an up-dip direction. The timing for the maturation is assumed to vary from Middle Miocene to present. Next, we go to the source rock. The hydrocarbon was estimated in Sabah Basin are essentially very similar in composition and is predicted to have originated from source rock, which are the terrigenous organic matter. No discrete rich source of rock layers is identified or known. However, the organics are probably concentrated in the marine compact interval. For reservoir rock, the purpose of reservoir rock is to provide storage to hydrocarbon. Reservoir rocks for the Glamour Merah field consist of interbed sandstone with a non-reservoir formation of thin shales. Sandstone has a good reservoir characteristic due to its high porosity and permeability, which can channel through hydrocarbon. For Glamour Merah, the formation is of anticlinal features, either from the growth faulting or anticlinal features associated with tectonics. To be assumed, there is also a stratigraphic traps unrelated to the anticlinal features, as the unconformity trapping mechanism that traps in the hydrocarbon in our location of interest. And the last one is silts. Silts rock aim to provide a barrier of migration for the hydrocarbon that result in the accumulation of petroleum. Lithologists of Glamamera 3, 4 and 5 found out that there is a presence of claystone, which is a good type of silts rock in the reservoir because it has low porosity and permeability, which prevent petroleum from migrates to another place. Now, let's go to the depositional environment. This part was obtained before the static model is generated. For Glamamera reservoir, the depositional is identified by a deltaic environment. Based on the core data report, a less considerable variation in grain size and sorting was observed within the sand body contained in the interzone units. Comparing with the depositional environment of Glamamera field was determined by analyzing an log interpretation. This interpretation were identified by using gamma array log reading. According to the log interpretation of Glamamera 3 and also Glamamera 4 well, we identified that it has a serrated shape. This shape indicates fluvial floodplain, distal deep marine slope, and storm-dominated shaft. Moreover, from Glamamera 3, 4, and 5 well log interpretation, the hydrocarbon was found initially sandstone reservoir because it shows a low resistivity log reading from the resistivity log. Shale in the Glamamera field were identified to have a hard, well-compacted micro meshes and smoothly sloping from the core analysis data.
This is static modeling for petrel. This is the contour map that we received for this project. It is a contour map that has plotted Glamamera 3, Glamamera 4, and Glamamera 5. From this contour map, we could create a static modeling using Petrel software. The static modeling from the Petrel software are as follows. This is the skeleton that was constructed based on this contour map. From here, we can see the shape and the size of the exact formation. This is the 3D modeling for the contour map.
Hello, Assalamualaikum. Today I will talk about GHG part, which is first one is gross rock volume. So the gross rock volume is the volume of rock between top and base reservoir surface and above a known or postulated hydrocarbon water contact in geological crack. GRV was calculated in unit volume, which is acre feet or meter cube. In this case, we calculated in acre foot unit. To get maximum area, the area that we calculated from USJ was multiplied by 0.95 and then we get the maximum area. For the most likely area, we calculate by multiplying the max area with 0.9 and minimum area was multiplied by 0.75. So this is area in MSJ then in maximum, most likely, and minimum area that we get in meter cube. So this is stock tank oil initially in place, or STOIIP. The HCIIP is an acronym for hydrocarbon initially in place. For oil, this is TOI. And for gas, it's GIIP, gas initially in place. HCIIP is function of gross rock volume multiplied by the NTG, net to gross, porosity, and oil or gas saturation, SO or SG, which is in this case we don't have gas, so we multiply with SO. divided by formation volume factor of PO. So this is the formula. Start is in unit barrel of liquid, BBL for oil volume, and cubic feet for gas volume. So this is the start value that we calculated. The first one is for GM3, unit 1 and unit 2. And we have three we have three value of start, which is max, most likely, and min. So as we can see, the value is in acre. So uncertainties method to calculate the gross rock volume of the reservoir from the topographic map provided. So the uncertainties that we accounted when calculating the gross rock volume is the map itself is insufficient for us to calculate the gross rock volume, and assumption of 1,000 meter equals to ratio to 164 pixel was applied to the ImageGeo software. So this is a very rough scale that was given to us. And next one is disproportion of water oil contact depth from the well log and the MDT pressure plot. So the MDT plot and the log that we have generated from tag log was not in the same depth, but here comes the fourth uncertainties, which is we shift the log, but we are uncertain of the shifting of the log value.
To conclude, Geology and Geophysics provides an insight on the petroleum system of the studied field with the application of mathematical engineering analysis and the assistance of engineering software such as TechLog, Petrel, and ImageG. The analysis shapes the foundation of petrophysics, drilling engineering, and reservoir engineering to fully understand on the reservoir's formation properties and behaviors during all production cycle, starting from development phase to abandonment phase.
Assalamualaikum, my name is Mohd Sayhir, and now we proceed with the field development plan 1 of Petrophysics. The objectives is to evaluate the petrophysical properties of the formation physically and chemically, to provide insight on the content of fluids in the formation, and the well log interpretation provides partially accurate formation evaluation. Next, we proceed with the data availability. The data and information available for petrophysics evaluation are listed below. The data provided were provided from the Geology and Geophysics Division and Field Testing. So here are the table of the data availability.
Next is parameter derivation. The first parameter that can be derived based on the log interpretation is water resistivity. Water resistivity of connect water in the zone of interest could be analyzed from the resistivity log, where salt water, which is brine, is usually low in relative resistivity, while fresh water has high reading for the relative resistivity using the log. Next is Picket plot. Picket plot is used to determine the value of water resistivity. The graph is constructed based on the value of porosity against resistivity of the formation. Picket plot also is plotted based on the derivation from Archie's water saturation equation, and the slope of the plot represents the water resistivity which indicates a resistivity value of 0.2815. This value represents brine water exists in the zone. The second parameter is shale volume. The rock shale volume can be estimated using volume of shale linearly from gamma ray log reading. From the calculation, the average shale value of Glamorera-3 for sand unit 1 and 2 are 0.35 and 0.45, while average shale volume for Glamorera-4 for sand unit 1 and 2 are 0.29 and 0.25. Next is porosity. The combination of neutron and density logs is an excellent source of porosity data, particularly in complicated lithology formation. From the calculation of porosity, Glamorera-3 for sand unit 1 and 2 have the average porosity of 0.31 and 0.28 gram per centimeter cube, while average porosity for Glamorera-4 for sand unit 1 and 2 are 0.31 and 0.3 gram per centimeter cube. The last parameter that can be derived is water saturation. Water saturation can be described as a proportion of water formation in the undisturbed zone. To calculate water saturation, the most suitable equations are using Simonduk's equation and Weizmann-Schmidt and Sommer's equation. This equation is suitable for shaly sand reservoir and clay conductivity from log analysis, and SCAL is taken into considerations. From the data, the average water saturation for Glamorera-3 for sand unit 1 and 2 are 0.6 and 0.5, while the value of average water saturation for Glamorera-4 is not present, as the well does not have water zone.
This is the full interpretation for Glamorera-3 and Glamorera-4. Glamorera-3 have two units, Unit 1 and Unit 2. For Unit 1, the total thickness is 211 meters from the depth of 998 meters depth to 1,209 meters depth. The type of rock identified are clean sandstone and shaly sandstone, where the clean sandstone is from 998 meters depth to 1,144 meters depth, while shaly sandstone is from 1,144 meters depth to 1,209 meters depth. The fluid type identified in Unit 1 is oil. It is a permeable zone, and the reading of the logging tools are as follows. It has a low gamma ray reading, low neutron density reading, and a few butterfly effects, and medium to high resistivity log reading. Acoustic has low compression. Glamorera-3, Unit 2. We identified that the thickness is 195 meters from the depth of 1,423 meters depth to 1,618 meters depth. It is identified that the type of rock is shaly sandstone and clean sandstone. Shaly sandstone starts from 1,423 meters depth to 1,480 meters depth, while the clean sandstone starts from 1,507 meters depth to 1,680 meters depth. The fluid identified in this unit are oil and water, where the oil-water contact is at a depth of 1,480 meters depth. It is a permeable zone. The logging tool reading are as follows. Gamma ray has a low to high reading because of the shaly sandstone formation. The neutron density has a low reading and multiple butterfly effects. Resistivity log reads medium to high, and acoustic has low compression. For Glamorera-4, Unit 1, we identified that the thickness is 185 meters, while the depth starts from 970 meters depth to 1,102 meters depth. The type of rock is clean sandstone only, while the fluid type identified is oil. It is a permeable zone. The logging tool reading are as follows. Gamma ray has a low reading, thus it is a clean sandstone. Neutron density log shows a low reading with multiple butterfly effect, and resistivity is low, while acoustic has high compression. For Gelama Merah 4 Unit 2, we identify the total thickness to be 204 meters, from the depth of 1,146 meters depth to 1,350 meters depth. The type of rock identified is clean sandstone only. The fluid type is soil, permeable zone, and the logging tool reading are as follows. The gamma ray log is low, showing clean sandstone. Neutron density is low with multiple butterfly effects, and the resistivity is from high to medium. Acoustic is high compression.
And now we are going to identify the fluid type and also the contact determination based on the pressure plot. Pressure plot is constructed to determine the depth of oil-water contact and gas-water contact, but in this project we are only identifying oil-water contact. The pressure plot can be constructed by using the given modular dynamic tester or MDT data. So this is the MDT data that have been obtained from the Gelama Merah 3 and also Gelama Merah 4 wells. This data will be plotted inside the pressure graph. After we have already plotted the MDT data inside the pressure graph, we insert two lines, which is the hydrostatic line and also the oil line, that with respect to the oil gradient. For the oil line, 0.36 psi per feet, and also the water gradient 0.431 psi per feet for water line. These two lines were inserted to identify the best fit for this MDT data, and from these two lines we obtain the intercept, which indicates the possible oil-water contact, that the possible oil-water contact were obtained at 1,490 meters.
Okay, now we proceed with the sensitivity analysis. There are two sensitivity analysis that we've done, which is porosity cutoff and visual cutoff. For porosity cutoff, the lower limit of porosity that indicates a proven productive section of a formation is referred to as the porosity cutoff. It was done by removing the non-productive rock by referring at the low value of permeability and porosity. Here we have the graph for porosity cutoff, and the value we got is at 90%. For visual cutoff can be produced by removing large volume of non-productive rock such as shale. By plotting HPV versus visual data, the cutoff can be identified as soon as the profile shows constant value of HPV, and the visual cutoff are measured at the 48%. Now we proceed with the net to gross determination, NTG. Net to gross, NTG, can be defined as the ratio of pay zone to the gross interval thickness of reservoir volume. The local reservoir interval containing commercially producible hydrocarbon is known as the pay zone. The equation of NTG can be shown below. NTG equal to net sand over of gross interval. Based on the value of the NTG obtained, the value of NTG is quite high, which very preferable to have high value of NTG. NTG used to determine the volume of rock that able to store hydrocarbon. Thus, the high value of NTG means that the rock can produce high value of oil reservoir. So here we can see the table result of for NTG of GM3 and GM4.
This is the conclusion for Petrophysics. we have concluded that the shear volume for each unit is 48%. The total porosity for each unit is 19%. The water saturation for Gelama Merah 3 is 0.5 for Unit 1, 0.6 for Unit 2. The net to gross for Gelama Merah 3 is 0.67 for Unit 1 and 0.5 for Unit 2. The net to gross for Gelama Merah 4 is 0.85 for Unit 1 and 0.99 for Unit 2.